next session will be led by Mo Abu Ali, Managing Partner, IoT CO, speaking about how to leverage AI and predictive analytics towards zero downtime, zero defects manufacturing. The presentation will educate the attendees on the digital tools of the trade to realize Industry 4.0 in a systematic approach with focus on the business case ROI, real-time connectivity, and predictive AI-enabled technologies for maintenance 4.0 and quality 4.0. Mo is a strategic and transformative technology and business management leader with 23-year record of achieving driving and sustainable change in manufacturing. He serves international and manufacturing clients in automotive, aerospace, and defense, providing digital transformation, IIoT, and predictive analytics technology and services, and the IoT Academy for Industry 4.0 training. Mo has a doctorate degree in industrial engineering and has worked with companies like IBM, P&G, Omron, and Toyota. Once again, after Mo has finished his presentation, we'll open the virtual floor for questions. As a reminder, if you have any questions during or after the presentations, please post them in the Zoom questions box. Over to you, Mo.
Thank you very much, Mario, for the introduction, and thank you for inviting me to give this presentation at your event. I really, really appreciate it. It's been a very informative event, so I'd like to kind of build on the previous speaker presentations, and I'd like to focus on case studies of implementing industrial AI solutions and predictive analytics in manufacturing. I'm very passionate about manufacturing. I've been in manufacturing since I was 20 years old. I've had the pleasure of working in a variety of industries, but I would say the industry that stuck with me the most has been the automotive industry. We as an organization, IoT Co is the Internet of Things company, and our DNA is the automotive industry, but over the years, we've progressed into a variety of discrete manufacturing industries, such as aerospace, CPG, and so on and so forth. We provide Industry 4.0 solutions, but one of the key solutions that I'll be discussing and educating more on today is how can you leverage artificial intelligence-based analytics toward maximizing uptime and maximizing quality in your operation. So our vision and your vision, if you're within a factory, is how can you go toward a near zero downtime, zero defects mode of operation. And there's a lot of tools out there. Sometimes it starts by getting education and doing an assessment, and education like attending an event like this today. And the other organizations have more maturity. They're collecting data, a lot of data. They don't know what to do with the data. So how can you mine that data and drive toward results? Speaking of results, one of the previous speakers mentioned, AI, machine learning. I mean, these might be new namings, but they've been around for many years. However, the cheaper sensors and cheaper hardware technology and more affordable cloud solutions and IT infrastructures and 5G and many of these things that you hear about have become enablers to allow manufacturers to implement these solutions fairly quickly and affordably. And this is actually an example of 3 manufacturers that have been awarded by the National Association of Manufacturers, NAM, in the US, for AI analytics leadership, okay? The first year the award was given was actually 2019. So we've seen manufacturers receive this award year on year ever since. And, not going through each case study one by one, but highlighting 4 keywords that are kind of enablers for manufacturers when they're going through their journey, their AI journey, predictive analytics journey, is 1, what is the value, the technical value of the solution to your organization? What problem are you trying to solve, right? How is it going to impact your production, your quality, your maintenance, okay? The second is speed or velocity. Velocity is speed times direction, going in the right direction. How quick can you implement those solutions in your business? Third is scalability. What type of skill sets do you need within your organization to sustain those solutions? And are you able to be empowered within your own organization to learn those solutions and scale the solutions quickly across your plan? So how scalable is that technology? And last but not least, value, time, and speed to scale equals return on investment for your business. Okay, and we'll talk a little bit about ROI, but on average, we're seeing manufacturers achieve ROI from these type of solutions within 6 to 12 months if they're implemented on the right plant, the right critical assets within their operation. So people, process, technology elements allow you to assess where you are and implement the solutions at the right pace and scale them fast. This is an example from a wheel manufacturer who implemented predictive maintenance, is an example in the die casting industry, high pressure die casting, which I'll show later on how they implemented a predictive quality solution that was able to track every part being produced on the casting cell and actually make decisions and prescribe action, which part is a good part, which part is a bad part, and even feed data back to the cell. So saving 1% scrap reduction in a mid-sized casting facility was almost $250,000 savings. So think about your why. Why do you want to implement such solutions? What is the business case, the business driver? And that'll support you to implement faster and scale faster. So I'm here to talk about three things, and at any time, just please drop a question in the Q&A. What is the umbrella of Industry 4.0 and the solutions that are part of that as pertaining to a manufacturing facility? And what is one of those tools driving the Industry 4.0 movement, focusing on leveraging advanced analytics and AI? And then, a summary of how can you get started by actually doing a digital assessment, understanding your current state, and selecting the right solutions for your business. IoT, Internet of Things. This is not a new naming, IoT has been all around us for decades. My wife works at GE Aviation. She monitors jet engines that have been flying in the sky. When an engine, goes up, cruises, and lands, there are actually snapshots of data that are being sent. And before the engine lands in airport B, there is predicted potential failures and spare parts that are needed. And they want to fix the engine before it starts to fly again. They want to maximize the uptime of the engine. Actually, General Electric, GE, they call it power by the hour. They don't sell you engines. You actually lease the engines and you pay as long as the engine is running and flying. That's a great IoT solution. It's a smart connected product. But where we play in a smart connected factory is multiple IT systems that are in some case siloed, or in some case don't exist, or in some case they are new or old, vintage systems. So you have your shop floor, you have your top floor. So your IT and OT. And one of the big challenges of why Industry 4.0 has been around is to actually help fill that gap and lead to convergence from this IT business layer, like your ERP system, down to your OT operational layer, which is your machines, your CNCs, your PLCs, your sensors, a lot of the conversations and presentations that my fellow colleagues have shown today, right? So when we talk about wanting to implement AI and predictive analytics, we first need to think, what is our digital strategy? What is our analytics strategy? What is the digital maturity of our organization? And then what are the best solutions I should pick for my business, right? Do I need a CMMS? Do I need a better data acquisition system? What type of wireless or wired vibration sensor should I use, right? So we're in the business of supporting clients to run those digital transformation assessments and roadmap your journey so that you can start selecting the right solutions for your business and implementing and executing fairly quickly. And one of those key tools is artificial intelligence and predictive analytics. It's a key driver toward Industry 4.0. And if you haven't heard, Industry 4.0 was originally formed by the Fraunhofer Institute in Germany with a lot of prominent companies, and it proliferated around the world. In the US, for example, we refer to it as Manufacturing 4.0 as part of the National Association of Manufacturers. But regardless of the naming, Industry 4.0 is about using digital tools software, sensors, hardware, IT infrastructure needs, right? In order to combine it with traditional manufacturing practices, your critical stamping press, your CNC machine, your robotic, in order to achieve return on investment and maximize throughput in your business, okay? So going back to starting with why should I implement AI and predictive analytics in my shop floor? And what use case makes most sense to my business, okay? Are you looking for visibility, data capture? Are you looking for predictive maintenance on critical assets that are uptime critical? 1 minute of downtime is expensive for your business. When I worked at Toyota 20 years ago, 1 minute of downtime on a car assembly line was $10,000. That's an expensive downtime. 1 minute costs you a lot. You're not making cars, right? So what's the power of uptime in your business as it translates to dollars? And predictive quality, right? We talked about casting. 1% casting scrap reduction could be $250,000 in savings, right? So start with why and think about the power of 1%. 1% reduction in maintenance, 1% reduction in scrap, right? And think about, how do you measure success? One of the challenges in implementing AI and predictive analytics is actually not the technology itself. It's usually the people and the process and the return on investment that is achieved, okay? And therefore, you have to set clear success criteria, whether you're improving OEE, labor efficiency. There is usually a link to sustainability and also energy capture, energy consumption. You want to shift the mindset of the organization from being reactive to being predictive and even prescriptive, where you can autonomously prescribe actions and control the process based on, machine health and predictions of what's happening. So start with why and understand your digital maturity within your organization. This is actually an example of an Industry 4.0 maturity index. And it's important initially, even within one manufacturing plant, your stamping operation, your welding operation, your CNC operation might actually have different levels of digital maturity. So by assessing the maturity of where you are, and if you're still here, this is Industry 3.0. You want to get connected, you want to fix your infrastructure, you want to start capturing data from critical machines, and then you want to hop the wall into Industry 4.0 by becoming visible, transparent, and predictive, okay? And I'll be talking more about how you can make that jump into the AI and the predictive world by leveraging quick implemented solutions. This is not a quiz question, but survey says, what is the #1 most widely used software tool in a manufacturing plant? And the answer is not a joke. It's your favorite tool, Microsoft Excel. And a lot of companies are using Excel to track production, to track spare parts, to track tools, right? You got a lot of great CMMS companies here that are also giving presentations. So how can we start shifting the mindset by capturing real-time data from the shop floor and enabling you to make the jump into advanced analytics and AI? And it all starts by understanding what is the level of digital maturity within your organization. And I'll come back to that at the end. So talking about AI and predictive analytics, and I'm showing a few quick case studies. Artificial intelligence is a science, okay? It is the science of getting computers to act intelligently without being explicitly programmed, all right? And that's science that requires mathematical knowledge and STEM knowledge, right? Science, technology, engineering, math. Has a subdiscipline, which is machine learning. And machine learning is math-based algorithms. You might hear the term algorithms. We're using algorithms. Well, algorithms are code, software code that can be trained. You give it baseline data, you train it with a few weeks of data or whatnot, and it builds a baseline of the current condition of the machine or the part or the component that you're tracking. You might also hear the term deep learning. Deep learning is a further subset of machine learning, and it's about using specific types of algorithms like neural networks that deal a lot with unstructured data. So you might hear about fancy cameras that have AI built in, right? Those cameras might be using deep learning algorithms that can take pictures of a part, and from the picture, which is unstructured data, can actually learn if the part is a good part or a bad part, okay? So AI is all around us. You probably hear about it in the news every day, but in our world, industrial machine learning is being used in manufacturing as we speak to collect data from machines and sensors and to convert that data, training the models and validating the models to start understanding what is true machine health and what is true process health, okay? So you got two key things that you want to improve. You want to improve your uptime, you want to improve your process and the part quality that you're producing. So when we think about industrial machine learning, we think about the top two use cases, which is predictive maintenance, driving zero downtime, and predictive quality, which is driving zero defects. And there's a lot of solutions out there. Again, please assess what solution is best for your business, but it's all about using multivariate analysis and looking at data coming from potentially your PLC, your OPC server, your data historian, your SCADA system, maybe add-on sensors like vibration that may need to be added to the process. Within the AI solution itself, there is a systematic approach with which you can define a data model, right? So what do you got? You got a robot, you got a CNC, each type of asset or component requires different data parameters. We call it a data model. And that multivariate data model allows you to start running your machine learning, right? It's a series of algorithms that need to be trained and validated. And it becomes like an analytics workflow. From data to features, those are the metrics you would extract from the raw data, to a health model, a prediction model, a diagnostic model, depending on the type of data that's available. You might hear the terms supervised learning, unsupervised learning. So again, it depends the type of data and the condition of the data that you're collecting, and data quality and data integrity becomes very important to what you're trying to achieve. At the end of the day, garbage in, garbage out. You want to train your models with good validated data, and that allows accurate models and accurate predictions. But going back to the business case, what is critical for your operation? When I look at manufacturing and my 23 years, predictive analytics is never really a factory-wide solution. It's a critical asset solution. So, we thought about, hey, what are the most capital intensive, uptime critical, and quality critical processes out there where you can implement AI and have a quick bang for your buck, quick wins and scalable solutions, right? So you got robotics, you got machining, you got casting, molding, welding, extrusion, stamping, right? Some of these operations are uptime intensive, quality intensive, also energy intensive, right? You also have ancillary equipment like your facilities systems that might be critical, compressors and chillers and pumps and so on and so forth. So it's very important as part of your assessment to do a criticality analysis and to understand, I got 500 robots, 80-20 rule, 20% of the robots might be leading to 80% of the failures that you're seeing in the field. So think of that 80-20 rule and think what is critical for your business in terms of spare parts, frequency of failure, and impact of failure, right? What's 1 minute of downtime? What's 1% scrap mean to your business? And of course, there's implementation frameworks, right? Sometimes you have two sources of data that's flowing. You have to architect those solutions in an intelligent way. You have your machine layer. You potentially have a sensor layer, such as add-on sensors like vibration. You have an aggregation layer where there's a software solution that's bringing in low frequency data from the control and high frequency data from add-on sensors. That's like 1 hertz data and 1 kilohertz of data coming in. And then those ML solutions are able to kick in and normalize the data, understand the data, and convert the data into health, predictions, and diagnostics. And not just implement the solutions in a siloed fashion, but feed the solutions and close the loop with your other layers in your environment, such as your CMMS system, right? You want to tell your maintenance system to auto-generate a work order before the machine fails and optimize scheduling, optimize spare parts. So we don't suggest these solutions to be isolated data science solutions, but they're actually, intelligent solutions that are complementing your existing architecture. Two quick examples: industrial robots. If you're a robot fan, KUKA, ABB, Fanuc, Denso, there are certain parameters you can capture from each joint of the robot without adding any sensors to the machine, in fact. And things like torque, monitoring the torque of each joint or each axis of the robot, allows you to implement ML solutions that can predict with a very high level of accuracy, in fact, and a long lead time, specific failure modes, critical failure modes. Those are shown in red here, high impact failure modes, such as belts, backlashes, bearing failures, which can, cause significant downtime to your assets. So this is a good example of non-intrusive data collection. You can capture the data from the PLC. You typically don't need to add sensors to the machine. And then, fast forward, user experience is very important, right? A lot of these AI solutions fail in the field because they're not designed for the user. They're designed for a PhD or a data scientist. So think of the user experience and ensuring that the right information is going to the maintenance person who doesn't care if you're using a logistic regression algorithm, but they care, is the machine healthy? What is the prediction of failure? I want to get alerts before the machine goes down. And I also want to know a diagnostic. Is it axis 5 on the robot, or is it axis 6 on the robot that's going to fail, right? So health, prediction, diagnostic, and then, of course, the ability to do a root cause analysis and go deeper into the solution. Typically, you need 4 weeks of baseline data, okay, unsupervised learning, to build the condition of the robot, and then those solutions can start running, and they could be manually retrained or automatically retrained based on rules, if you're interested in some of the details. Machine tool, CNC machines, okay, much more complex than a robotic. There's a lot of moving parts here. There's a lot of subcomponents. There's a spindle bearing, there's a feed axis, there's a coolant system that has a pump and motor system. There's a tool on the spindle where you can also use vibration to detect and predict backlash and unbalance of the tool. And there's a data model, right? We talked about what's a data model. What data do I need to collect? There are CNC controller parameters you can collect. There's an add-on vibration sensor off the shelf that you can actually procure from PCB, IFM, from anybody, sensor agnostic. And you can capture the needed data and marry that data with the CNC controller parameters, such as the load, the current, the RPM. You can also monitor the ball screw system, your XYZ system on the CNC machine. And you don't need sensors for that. Usually you can use the position data to track deviation in the position of each ball screw. And that can actually help you predict ball screw backlash and other type of ball screw failure mode, lubrication, starvation issues, and so on. And again, the user experience. There's an example of a spindle bearing prediction where the bearing was healthy. Yellow and red are automated AI generated thresholds. You don't need a person to be looking at the data. The AI has the intelligence. You don't need to invest in a vibration certified analyst unless you can afford one to look deeper into the data. And then you have a diagnostic. It will tell you you're having an outer race failure of the bearing or an inner race failure of the bearing, and then you can actually validate, right? So predictions at a glance. What is happening to my machine? Is it healthy? When it could fail? And what is the root cause of the failure? So this kind of takes us to, quick summary. And of course, there are many more case studies. I'm sorry if I did not present a case study that pertains to you. Please ask me the question or email me, and I will email you, something relevant. But I just wanted to pick some quick snippets of case studies that are happening all around you by many companies, large and small. And it all boils down at the end to, how can I get started? Okay. I think it's important, again, to do an assessment, to understand the maturity of your organization, people, process, technology, to do these innovation workshops, to understand gaps, to have a total cost of ownership, TCO, what is the cost, hardware, software, services, and then to select the right solution for your business, whether it's a sensor, whether it's a software, and then to implement a proof of value pilot, which is usually a 90-minute duration pilot. And we don't foresee those pilots going beyond 3 months. Again, if an assessment is properly done and kind of architected the setup there, you know, these implementations usually take around 3 months. And it usually takes, say, another 3 months to run, validate, and start achieving an ROI from the solution. So if you're seeing that your implementation is going beyond that time frame, there's probably something wrong in the setup, and you need to reevaluate and kind of pivot back. Is it people? Is it process? Is it technology? What can I do to potentially go to a different plan, different critical assets, and think about it? We conduct those assessments. You may also work with other companies that can conduct those assessments. You know, those assessments look at what is the data maturity of your organization. Are you connected, right? What type of metrics are you using to drive your business? Some of the foundation stuff. What is your use case? Is it production, quality, maintenance? What is a quick win for your business? You know, what is the role of capturing process data? Which AI use case makes sense for you? And then, of course, what are the supporting IT systems and infrastructure that is kind of holding the foundation within your organization? And this becomes a blueprint that can then be used to select and implement the right solutions for your business and basically drive toward a return on investment very quickly. So, you know, I'd love to answer questions. I know this was a quick presentation, but think big, start small, act now. It's becoming a very competitive market, and being more competitive in your, you know, factory requires you to digitize, capture real-time data, and start driving toward analytics for your people. Consider an assessment if you haven't done that already. Make it operational with a proof of value, a pilot, using a business success criteria and the technology to be implemented on critical assets in your business to start. Continue having that vision of zero downtime, zero defects, and think about the AI use cases that make sense for your business for quick wins. And always evaluate, you know, what are the risks? Is it people, process, technology? Because benefits only really accrue as far as the weak link. So, you know, think about an area to start these pilots where you can maximize the potential of your people, process, and technology. Please email me for a copy of the presentation, or I think you will receive it also from our friends at MRO. And I appreciate your time and happy to answer questions.
All right, thank you very much, Mo. Lots of great technical information in your presentation. We now have some time for our question and answer part of the session. Please post your questions in the questions tab now. Let's look at some that have come in. What is your advice in finding the right predictive analytics technology?
That's a good question. Business case first, assessment, conduct a thorough assessment, think about what is needed in terms of data maturity, sensors, hardware, in addition to the software and services that are required. And always keep in mind speed of implementation as well as scale opportunity of the implementation. Given that you don't want to continue working with integrators and so on, you want to empower your internal team members and create your own center of excellence where you can actually scale these solutions yourself. So these are some of the criteria that are always kind of in the back of the mind to kind of select and implement the right solutions for the business.
When and where should you start implementing a predictive analytics program?
It's all about criticality. And again, I don't believe these solutions are factory-wide solutions. I believe they are critical asset solutions. You have to think of the use case that makes sense, whether it's production or quality or maintenance. You have to think about, you know, we had a customer that had 50 casting machines or 100 CNC machines in a shop. They had casting and CNC machining. They actually implemented two use cases. One was predictive quality in the casting operation because the scrap rates were higher than normal there. So quality was a bigger use case. They leverage AI for predictive maintenance in the CNC operation, where uptime and spare parts were a more critical business case. So business case first, critical asset selection, and then implementation of the right sensors, hardware, and software for your business.
Okay. Once the challenge of identifying and prioritizing the most compelling possibilities of predictive analytics has been addressed, the next step is to justify the economic business case. How are you calculating the business case in your business?
I would say, depending on the use case, but when it comes to predictive maintenance, we find that improvements in uptime are important by detecting and predicting unplanned downtime for specific failure modes. We also find an interesting link to spare part management. By having a predictive window, many clients can actually reduce spare part inventory, which can be costly in some situations. In addition to labor efficiency, by knowing a prediction window of when an asset will fail, they can actually schedule labor and spare parts and people in a better way. We have clients that completely eliminated weekend maintenance, overhead maintenance, firefighting on the weekend, Saturday, Sunday, and that saved them a lot of money by having these condition-based monitoring and predictive tools with the power of detecting, predicting, and improving uptime. So uptime and quality, scrap reductions are always key points, and it just depends which use case makes more sense to your business.
Okay, what main challenge have you faced in your organization while implementing a predictive analytics program?
In all honesty, it's not the process, it's not the technology, it's not the fancy sensors and hardware that everybody talks about. It's really the people, you and I. It's about change management. It's about making sure that these solutions are used properly, the right information for the right person at the right time. Give you a simple example. If an organization doesn't even have a CMMS, they are not doing their PMs, right? You should be talking to one of the CMMS companies that are presenting today and starting to level up your PM strategy, your preventive maintenance strategy. So there is a level of maturity that needs to be in place regarding the people and the systems. And if that is there, then absolutely, predictive maintenance and AI and predictive quality can lead to significant. So upskill your people, upskill your processes, and you'll be very successful implementing those solutions.
All right, we got time for one more question. How can I maximize my existing technologies to better complement my predictive analytics program?
I think that's very important. A lot of companies have invested in a lot of solutions, from your CMMS to your ERP to SCADA systems to your Kepware, your Ignition, whatever you're using to collect data, sensors, hardware. These solutions should not be a rip and replace solutions. They are solutions that should interoperate with what you have, okay? So there is a lot of APIs, there's interfaces, there is REST API, there is database connections that can be done. There is MQTT and a lot of open standard protocols that can be used to capture data from different systems, new systems and legacy systems. So think about how you could capitalize on the investments you've already made to generate even more ROI, even more value, before thinking about ripping and replacing. So I think interoperability is key. Look for solutions that can interoperate with your existing investments.
All right, and that's puts a wrap on our questions, and right at 3:20. Thank you once again, Mo, for a very informative session.
Thank you very much, Mario. Thanks, MRO.